So I work for Nuance Communications. If you don't know us, we are the global leader in interaction technology for automotive. That means handwriting, speech recognition, natural language understanding, and text-to-speech technologies for the car. Every OEM is a customer of Nuance. So the top 15 OEMs in the world, 15 are using a Nuance technology or solution inside their vehicle. So I will talk today about providing a more intelligent interface, a contextual interface inside the vehicle. And I think most people know today the idea of a personal assistant. There are personal assistants that are available in almost every mobile phone. You can find them now in home devices, home speakers. There are products available from companies such as Apple, Amazon, Google, and many others. At Nuance, our focus is on the car, the vehicle, the journey, and the driver. And we have this idea of an automotive assistant, which can be different than the other personal assistants you can find in other devices outside the vehicle. So our vision for the automotive assistant is based on three key ideas. The first idea is that the automotive assistant is there to help the driver throughout this entire journey. It's not just about being inside the vehicle. It's about preparing your trip, going to your vehicle, driving to destination, and then maybe completing your trip and walking to your final destination. That's the first idea. It's an assistant that is there to help you with mobility and your entire journey. The second idea is that the automotive assistant is there to perfectly meet the needs of the driver. Just like a human assistant is there to perfectly meet the needs of the person he or she is working for, the automotive assistant is a companion inside the vehicle and is there to meet the needs of the driver and to do so perfectly. The third idea in our vision is to have an assistant that is there to think for the driver. The driver may be presented with complex decisions to make in the vehicle. And what we want to do is really help the driver solve problems, make decisions, do some thinking for the driver to make sure that he stays or she stays focused on a safe drive. So what are driving-related needs? So we are doing research at Nuance to better understand what are the priorities of the drivers in various markets. We're doing a lot of research and surveys, and I'm going to show a short video of a few people, consumers, which we have interviewed in the UK.
What matters most to me when I'm looking for parking is the fact that it's safe, secure and convenient in close proximity to the meetings that I'm going to.
Obviously I like to park the car in areas that are secure. Mainstream car parks at supermarkets tend to be protected by cameras, so that's good.
Charging points. Charging points are quite important because it means I can charge the vehicle back up again once I'm there.
It's very important that there is a child-parent parking bay because it provides the necessary space for getting out a car seat, a pushchair, occasionally the dog.
When I'm looking for parking, what I'd like to find, often you don't know it, is somewhere reasonably near to your final destination.
When I'm going away for the weekend, what I really like to look up in advance is the hotel location, the parking location that's close to the hotel, and any cool bars and restaurants that I would like to go to on that weekend.
On the way there, it's quite useful to know where there's a petrol station, where there's a place to eat, restaurants, baby change facilities. It'd be useful if the car could tell me that.
For me, it's quite important to get the most eco-friendly route into London. Normally you find that route will be the quickest route. This vehicle I can get from home to work without using any petrol whatsoever.
It would be extremely useful to have my navigation and directions sent directly to my calendar, and obviously that uploads into my navigation system.
What I don't get at the moment is traffic conditions. You can look up on the internet, that's fine, but by the time you're halfway down the motorway, that information is probably redundant.
If I didn't have to actually have my hands on the steering wheel and drive, then I would love to be able to buy myself some more time and actually work on the go, to be able to prep for meetings that I was going to, and also potentially type up notes of meetings that I've just been to.
One thing I probably would find the auto assist useful for is if it could somehow work out how much charge I've got left in the vehicle and show me obviously the optimum route to get to the destination and tell me whether I'm actually going to make it on the charge in the vehicle without having to turn the power back to the petrol again.
It would be great to see some more sort of social media and kind of, feeds coming through my car, and I have those ready accessible and I'm fully connected in my car, basically on the go.
We had here some ideas and some needs from different drivers, consumers in the UK, and these needs fall into different categories. Some people want to be entertained in the vehicle. They want help with their car. We recently did a survey in the UK and Germany, and over 45% of the consumers surveyed said they would like an assistant, a companion in the vehicle that helps them make use of the vehicle features, solve problems, so really something, an agent that will help them optimize the experience with the vehicle. People want to be guided to destination. They want to be more productive in the vehicle or find great places for lunch, dinner, etc. So these are some examples of the needs that we're trying to address, and we're trying to really focus on providing an assistant that delivers the best possible experience and outcome for these drivers. So we mentioned in our vision that we're trying to provide a perfect experience and a perfect outcome for the driver, so to perfectly meet the needs of the driver. So how do we achieve that? What do we need to do from a technology standpoint to try to provide this result that these consumers want to have? We're looking at combining 3 different sets of technologies. So what we call interaction technologies, artificial intelligence, and knowledge-based systems. And it is a combination of these 3 technologies fused together, tightly integrated, that will allow us to provide to these consumers, to these drivers, an experience that delivers a perfect outcome, perfect results, and helps them achieve things with very low cognitive load, having systems that think for them and provide them the best possible results with no effort. So interaction, what does that mean? Interaction technologies are a range of technologies that work together to provide the best possible experience and interact with the driver. That includes, of course, core speech recognition technologies. It includes text-to-speech technologies to convert content into voice, to communicate back to the driver. It includes technologies to provide results, information in a manner that is more relevant to the driver, that's contextualized, if you want, information. It includes natural language understanding, to understand the intent of the driver. It includes additional technologies like voice biometrics, which is used to identify the driver and secure his information or her information, and technology to optimize the audio inside the vehicle. So we call this interference cancellation technology, so that if the vehicle has multiple passengers, that we can really have a one-on-one conversation with the driver and cancel the noise that other passengers may be making inside the vehicle. And finally, at the heart of all this is collaborative dialogue technology, technology that allows the driver to have a human-like conversation with the assistant inside the vehicle. So the second group of technologies is artificial intelligence. Here we're talking about contextual reasoning technology, technology to personalize user experience, and we can do this by learning from interaction or learning from data that we collect from the car and the driver, meaning extraction technology, and technology to plan things ahead for the driver. Finally, and equally important, is knowledge technology. So when we provide these more intelligent interaction, we provide artificial intelligence, we need to have access to a very broad set of knowledge about the driver, the passengers, about the vehicle, about the context. Is it raining? Is it not raining? The preference of the users, world knowledge. When the driver is expressing things, what do they mean? When the driver says French, does he mean a type of cuisine, or does he mean the name of an artist, or does he mean a person called French? So we need to have a very broad set of knowledge that is built based on data and information available from the vehicle, the OEM, the driver, and of course, content providers who provide us the data and information necessary to build this knowledge base. So how does this work? I have here an example, a simplified example on the user experience compared to mobile. And the experience here, the example, is about finding a parking in London. So I don't know how many people here are from London. I guess most are from the US. Anybody from London here? No? No one? Okay, so anyway, I'm sure you'll get it very, very quickly. So in this example, the driver is trying to find a parking near a POI in London. And on the typical web-based interface or mobile phone interface, this is what you would get. You would get basically a screen that shows you 25, 30 different parking around your POI. And when you drive, of course, you have to think, well, which one should I go to? You know, what is the price difference? Which one has maybe an elevator because I have a pushchair in the back? Which one has, you know, the best price? Which one is outside, inside? Very difficult when you drive and distracting to look at a screen with 25 pieces of information and try to make the right decision and to find the right parking that meets your needs. So, and this is true for many applications that are parking finders inside mobile phones or the web. So instead, what we really want to do is to find the perfect car park for the driver. And if the driver wants to find parking near POI, we have to be able to provide him the best recommendation that just meets the needs of the driver. But how do we know it's the right parking? And how do we allow the driver to be able to refine the search and to adjust the recommendation made by the assistant? So this is the user experience of the automotive assistant. The driver is asking for a POI, trying to find something. The assistant is going to use the knowledge base, the context, the information available to the assistant, do some reasoning, and then provide a contextualized recommendation. So use all the information available, apply some AI and reasoning, and provide a good recommendation to the driver. And that recommendation may not be the best one for the driver. And the driver may want to express by voice a different preference, so refine the search. You may say, well, today I would like something cheaper because I'm paying for the parking. Or I would like something with an elevator because I have with me an older person who cannot go up the stairs. So this can go several times, and we refine the search. Every time the driver is expressing a new preference, we're learning something from the driver. And ultimately, when we have the right recommendation for the driver can, of course, confirm that recommendation and express maybe another intent. And, okay, I like this parking, and let John know my arrival time. Or I like this restaurant, and share my arrival time with my friends so they know when I'm arriving. So here's some examples of how we can use knowledge, or how we use knowledge to provide a better user experience. So we have knowledge about the user, we have knowledge from the vehicle, we have knowledge from the content providers, from the user, for example. It can be something really simple, a payment preference. Does the driver prefer to pay with a certain type of credit card? Or it can be something more subjective. You know, what is the price sensitivity? You know, is $1 more a lot for the driver or not? Is $10 more or $10 saving something the driver cares about? Information about the vehicle. What is the location of the vehicle, the destination, the estimated arrival time. Your arrival time is important because the last thing you want to do is to drive to a car park that is closed by the time you arrive there, right? So you need to know in the context when you drive somewhere and ensure that the place you're going to is going to be open by the time you get there. And of course, online information. What is the parking location, the restrictions, the price, the features of the parking, the opening hours, etc. The last thing you want is to drive to a car park that is too small for your vehicle, or to drive a car park that doesn't have EV charging for your electrical vehicle. Here's some examples of contextual reasoning, and in our plans, we can see that there can be hundreds of reasoners in an assistant, hundreds of specialized reasoners or more general reasoners. So a personal reasoner would ensure that the car park you're driving to has an elevator if you require an elevator for accessibility or family or children reasons. We can do things like spatial reasoning, right? Ensuring that the walking distance is within what is acceptable to the driver. Temporal reasoning, ensuring that the POI is open by the time you get there. So here's a video, an example of a parking assistant that we've implemented. It's a simplified version.
I need parking near the Golden Gate Bridge.
I found 8 places near there. The closest is Presidio Anza Avenue lot, about 1 mile away. Want that one?
Drive to the Golden Gate Bridge.
Golden Gate Bridge, California. Would you like to begin navigation?
Yes.
Starting navigation.
Find parking near the destination.
I found 9 places near there. The closest is Fort Point, about 0.4 miles away. Want that one?
All right, so this is an example of one of the many reasoners, a very simple reasoner that is just checking that the POI you're trying to drive to is open at the time that you are going to get there. So how do we deliver our solution? We have this product called Drag and Drive. It's a solution portfolio that is based on 3 platforms, a framework, an embedded platform that is inside the car, a mobile platform, and a cloud-based platform to provide cloud-based services that extend the experience inside the vehicle. And these 3 platforms integrate all the technologies that we have, interaction, knowledge, AI technologies, and support the applications that we are building for our customers. So it's an automotive-grade platform. As I said, it's hybrid, combines 3 different platforms, fully customizable to meet the needs of our customers, and deployed in over 140 million vehicles. So you can see actually some of the platform in action. In the hall there's a BMW 7 Series that has the latest implementation of our embedded and cloud-based speech technologies. So as I said earlier, we're also looking at the experience outside the vehicle, and we're using our cloud technology to be able to bring the experiences across devices, so that the driver can start to plan his trip or stay in contact with his vehicle using smart devices, smartwatch or mobile phone, interact with the vehicle via cloud services, and continue the experience when he's inside the vehicle using the embedded platform that is in the vehicle. So to conclude, the automotive assistant, again, is different than any personal assistant on mobile devices. It is designed for automotive. It integrates artificial intelligence, knowledge, and interaction technologies that are designed and optimized for automotive use cases and the automotive context. And the idea here is to design an interface, a user experience that will delight and meet the needs of the drivers. Thank you, and if you want more information, feel free to contact me, and we have, as I said, a demo in the hallway. Thank you.